Oh, we see the musicians and hear the notes they're playing, and it sounds so great. But today, our friends at STEM NOLA are going to show us how to see the unique shapes of each musical tone. We're joined by STEM student Jordan Johnson from Holy Cross High and STEM NOLA Director of Education, Lela Lenoir. Welcome. How are y'all doing?
We're great.
Doing good.
I'm excited. Let's jump into this. How can we see sound?
Okay, so today we're making a tonoscope that we visualize sound. So today, what you'll need is a cup with a hole inside. You'll need a straw. You'll need a couple packets of salt, like a handful. You'll need a pair of scissors, and you also need a balloon. So today, first what we'll do is put the straw inside of the cup.
And like that goes through the hole, right?
Yes. Mm-hmm. Then what you'll need to do is you'll need to cut the neck of the balloon off so you'll be able to place it on top of the cup.
Okay.
Just like that. And then you want to open the balloon up and put it on top of the cup.
And you might need some help for this part.
Okay. All right.
You would like to put about 2 packets of salt on top of the balloon.
Okay. All right.
And then
yeah.
what you like
there
to
you
do
go.
is put your mouth on the straw.
Yep.
And like to make sound. Ooh, 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 ooh. Okay.
Perfect.
Oh, cool.
Okay, and this is just showing there is actually a study of sound, and it's called semantics, and it shows that sound actually has a distinct geometry, just like a crystal or a flower or nautilus shell. We all know sound's a vibration, and it's a wave of pressure that goes through air and water and solids, just like the balloon. And you don't even have to be able to hear to experience sound. If you've ever been in your house and a car with a really booming bass system goes by and you feel that, mm-hmm. you know that you've been experiencing the vibrations of sound.
Wow.
So I have a question for you.
Oh, well, Jordan, let me ask you one real quick first. Each one of these different notes will actually make a different wave. Is that kind of what you're explaining to us today?
Yes, sir. Mm-hmm. The different notes with your sound in your mouth makes it. But I have a question for you.
All right, throw it at me.
Do you know how the salt moved?
How does sound move?
Do you know how the salt moved?
How the salt moved? Is it through the vibrations in that balloon? Is that kind of the balloon kind of holds onto those vibrations and then sends it through the salt?
Yes, but to further explain, the vibration from my mouth went into the straw, into the cup, making the balloon vibrate, making the salt move.
Yep, perfect. So, and we're going to have, of course, you can go to stemnola.com and register. Our next build coming up is a brand new build. We have free registration. The next build's on December 11th, and we're doing virtual and in person. This is a brand new build. It's going to be, one of our builds is going to be Santa, as you can see. We've got a Santa sleigh. This is going to be circuitry and illumination. So this is going to be something really interesting. You might want to do this one yourself. Yeah. So, we have a lot of really cool stuff, and you can go to stemnola.com and find all of it.
A really, really great resource for anybody who's interested in all of that. Yes. Lee Jordan, thank you so much for joining us today. I'm going to be thinking about those waveforms going when I'm listening to music the next time. You guys did a great job explaining that, and you can make that right at home. Thanks so much for joining us.
Thank you.